Okay. So in the first class, I have seen that some of you attended the class, attended the meeting, and then left the class. Maybe you stayed 1 or 2 minutes, and some of you stayed like maybe 10 minutes. So if you just join the meeting and leave the meeting, that doesn't mean that you attended the class. So actually, I have all the records, like when you are joining the meeting and when you are leaving the meeting and how long you stayed in the class. Okay. So in the last class, we covered chapter 1. In today's class, we'll go over chapter 2. And I think we need 2 classes maybe, or 1.5 classes to finish this chapter. So this chapter is about organizing data. So how first you need to collect the data. So in the last class, we learned the simple random sampling, and also we didn't discuss actually any other type of sampling in this class. We just discussed about simple random sampling. So after collecting data, the next task is organizing the data. So now in today's class, we'll learn how can we organize our data. So in section 2.1, we'll discuss about different type of variables and data. So what is variable? The variable is a characteristic that varies from one person or thing to another. So what does it mean? So if you think about the height of a person, so the height of persons actually is differ from person to person, right? So that's mean this is a characteristic of the person and that varies from person to person. So this is also a variable. Or if you consider the weight of a person, and the weight of person varies from person to person, right? So this is also a variable. Or you can say the CGPA of a student. So this is also varies from student to student. Okay. Or the midterm grade, or the first exam grade for this class, who is also differs from student to student. So this is also a variable. So there are different type of variable. So first we can divide the variables into 2 types. The first one is qualitative and the second one is quantitative. So what is qualitative variable? The qualitative variable is non-numerically valued variable. So that's mean the variable which doesn't take any numerical value. So which takes only non-numerical value. So for example, we can consider, for example, if the response is female or male, then it is non-numerical variable, right? And quantitative variable, it is numerically valued variable. So person's height, person's weight, or age, this is numerical variable, right? So this is quantitative variable. And then quantitative variable also has 2 types of quantitative variable. One is discrete, the other one is continuous variable. So what is discrete variable? A discrete is quantitative variable whose possible values can be listed. So that's mean we can list all the possible values of that variable. In particular, a quantitative variable with only a finite number of possible values is a discrete variable. So for example, if we say the number of newborn baby in a family, so we can list the number of newborn baby, right? So in a family, the number of newborn baby could be 0. It could be also 1, 2, 3, 4, 5, 6, or more than 6. Not newborn baby, now a number of baby in a family, or number of children in a family. Or we can consider also some other example. So number of student in math 2300 class in different sections. So math 2300 class has different sections, and each section has a fixed number. So, and this number also varies from section to section, but we can list all the numbers, right? So this is discrete variable. But continuous variable, a quantitative variable whose possible values form some interval of numbers. So we cannot list all the possible values of this variable. This is called continuous variable. For example, if we say weight of a person. So we cannot list all the possible values of weight of a person. The person's weight could be 150 pounds, it could be 130, it could be 130.1, it could be 130.3, or it could be 130.3, 133.5. So it has actually so many possible values. So it can take fractional numbers. So we cannot list all the possible values. So this type of variable is called continuous variable. Okay. So here, this is the figure for types of variables. So this is the graphical representation. So first, this is variable, and the variable has two types. One is qualitative, the other one is quantitative. And the quantitative variable also has two types, discrete and continuous. So we already know what is discrete variable and what is continuous variable. We will also see some more examples. Okay, so now we'll define data. So what is data? Data is the values of a variable. So for example, if we consider the number of baby in or number of children in a family, so then if our variable is number of children in a family, then the values could be 0, 1, 2, 3, 4, 5. So if we have if we consider 100 families, and if we collect the number of children for each family, then these values will be called the data for that variable. That's mean the values of a variable. And qualitative data. So what is qualitative data? Values of a qualitative variable. So if we consider a qualitative variable, then the values for that variable is called the qualitative data. And quantitative data is the values of a quantitative variable. And discrete data, and which is the values of a discrete variable. And continuous data are the values of a continuous variable. Okay, so here are some example of variables and corresponding data. So first one is qualitative variable. So we have two variables here. First one is blood type, and then second one is marital status. So, and we collected blood type for different person. So the blood type for the first person is A, for the second person is B, then B, O, then blood type is A, B. So these are the data we collected. These are the values of blood type, right? So this is called the data, and this is qualitative data. So marital status, this is also qualitative data. And we have also discrete variables. So we have two discrete variables here, number of siblings, and this is the corresponding number for siblings. So the first one is 1, second one is 3, 0. So this is the values of this variable. So that's mean this is called the data for this variable. And this is the number of pets. So here we have the values for this variable. So that's mean this is called the data for this variable. Since this is discrete variable, so the data is discrete data, right? And we have also an example of continuous data. So continuous variable is weight of newborn. So this is the weight of newborn. So we considered 5 newborns, and we measured the weights of the newborn. And we have 6.2, 7.1, 8.99, 8.72, 9.223, 6.07. So this is the corresponding data which is related to these variables, weight of a newborn baby. Okay. So do you have any question? So what is variable, and what type of variables we have, and what are the examples of different type of variables? Do you have any question? Okay, so here are a few more examples. So here are some examples of discrete variables. So number of students present. So number of students present in this class is 113. So 113, and we also, if we consider the other sections of this class, and if we count the number of students for each section, and if we collect that numbers, that will be called the data for this variable, right? Number of students present. So number of red marbles in a jar, and number of heads when flipping 3 coins. So why number of students is discrete? Because we can list all the possible values for this variable, right? So number of students could be 100. So in this class, number of students present is 113. So in the other section, it could be 90, 93, or 95, or so it doesn't take any fractional numbers, right? We can list all the values, all the possible values, or it could be also 0, 1, 2, 3, right? Yeah. So continuous variable, height of students in class. So can we list all the possible values of height of students in the class? So what could be the possible values? So it can take any numbers, right? The height can take, so it could be 5 feet 6 inches, or it could be 6 feet 2 inches, right? So it can take any number. So that's why this is continuous. Weight of students in the class. Weight also can take any number between a certain range, right? So that's mean this is also continuous variable, because we cannot list all the possible values corresponding to these variables. And time it takes to get to school. So this is also continuous, because we cannot list all the possible values for the time to get to school, right? So that's why this is continuous variable. So is it clear the difference between continuous and discrete? Yes, sure. The discrete variable, it takes discrete numbers. Discrete numbers means we can list all the possible values. So if you consider the example, the newborn baby, or the number of siblings in a family. So number of siblings means it could be 0, 1, 2, 3, 4, 5, right? Maybe 6, 7, 8, maybe maximum 10, or it could be also more than 10. But whatever it is, we can list all the possible values, right? So now think about the height of a person. So can you list all the possible values of height? So for example, if the minimum height is maybe, for example, if the minimum height is 4 feet 6 inches and the maximum is 7 feet, then what are the possible values of the height of a person? Can we list all the possible values? No, discrete number. Yeah, good question. Can discrete numbers only be a whole number? No. The discrete number also can take fractional values, but the thing is that we can list all the numbers. That means we know all the possible values of that variable. If you can list all the possible values, even it is fractional, that will be also called discrete. You will also see some example like of discrete variable which has fractional numbers, but all the numbers are, all the possible values are listed. Yeah, thank you. Do you have any other question? Okay. Okay, thank you. So then next we have, so this section about this section is about actually different type of variables and example of different type of variables. The next section is section 2.2, which is organizing qualitative data. And then we'll discuss about organizing quantitative data. So how can we organize? First thing is we'll collect the data. Then next thing is organizing the data, and then we'll summarize the data, and then we'll analyze the data. So how do we organize the data? So we can organize the data in different way. So for qualitative data, we can use frequency distribution or relative frequency distribution or different graphical representation. So the frequency distribution and the relative frequency distribution is the tabular representation of the data, of the qualitative data. Or we can also use frequency distribution and relative frequency distribution for the quantitative data as well. Okay. So our frequency distribution of qualitative data is a listing of the distinct values and their frequencies. So that's mean in one column, we'll list the possible values of the variable. And in the second column, we'll list the frequencies of each values. So if we consider the previous example, the blood type, so we had possible values A, B, O, and AB, right? So we have 4 different type of blood types. So this is our variable is blood type, and this is the corresponding value of this variable, the possible values for that variable. So now how many times we had A? So that's the frequency of A. And how many times we had B? That's the frequency of B. And how many times we had O? That's the frequency of O. So here, this column actually the corresponding frequency. So this is the value for the variable. And this here you will write the corresponding frequency. If we have blood type A 4 times, then the frequency will be 4. If we have B 6 times, then it will be 6. If we have blood type O 10 times, then the frequency will be 10. And if we have blood type AB 20 times, then it will be 20. So the frequency distribution, actually, this is called the frequency table. In the frequency table, in the first column, you will write the variable name and its corresponding values. And in the second column will be the frequency. So that's mean the frequency corresponding to its distinct values of the variable. Okay, so we'll go over some example, and then it will be more clear to you. So to construct a frequency distribution of qualitative data, list the distinct values of the observations in the data. So that's mean you have to list the distinct values of observations. So the first column, you will list the distinct values. So in the previous example, we listed A, B, AB, O, right? In the first column. Then in step 2, for each observation, place a tally mark in the second column of the table in the row of the appropriate distinct value. So that's mean actually, if you do not know the frequency, if you need to count the frequency, then to count this, we use tally mark. So here, this is the variable name. Then this is tally mark. Then it will be frequency. So this is the frequency distribution or frequency table for the qualitative data. So now step 3, count the tallies for each distinct value. So here you will have tally mark like this. So each bar represents actually one number. So that's mean we have, if you have this tally marks, then that's mean 1, 2, 3, 4. If you have more than 4, then we'll write like this. This means actually 5. If you have more than 5, then you will write, for example, if we have 7, then you have to write the tally mark like this, 1, 2, 3, 4, then this cross line, which means this is 5, then 2 more, that means 7. 5 plus 2, 7. So this is 7, this is 4, sorry, this is 5, and this is 4. Okay, so now we'll go over an example. So here we have political party affiliations of the students in introductory statistics. So we did a survey. Actually, we didn't do the survey. So they did a survey to the statistics class, and students about the students political party affiliations. So, and here are the responses. The first response is Democratic, then Republican, and so we have three distinct responses here: Democratic, Republican, and other. So we have three distinct responses. So in the first column, it will list all three distinct values, right? And in the second column, we will use tally mark. And in the third column, we'll count the number of occurrences. So here, the first column is the variable, the party, and its distinct values. So here, party is the variable name or political party affiliation. So, or simply you can just say party. So we have three responses, three distinct responses. Actually, we have 40 responses, but we have three distinct responses. So we listed all three distinct responses here: Democratic, Republican, and other. Then we used tally mark to count the number of occurrences. So how many times we have this response, Democratic response? So how many times we have this response? One, so you will use just one tally mark. Then we have two, another one. Then we have here another one. Then we have another tally mark. Then another Democratic here. Then we have another one here. That's mean we have 5. Then we have one more. Here we have another one. Then we have here another one. Here one more. Here another one. So we have 10 up to this. Then we have one more here and another one here. This one here. So we have total actually 5 plus 5, 10 plus 3, 13. So we have 13. Actually, we use this symbol so that you can easily count. But if you use just this tally mark, then you have to count 1, 2, 3, 4, 5, 6. But if you use this notation, then you can easily count. This is 5. So you do not need to count this, right? So if you see this symbol, that means this is 5. So this is another 5. 5 plus 5, and we have 3 more. So 5 plus 5 plus 3, that's mean 13. So for Democratic, we have 13, right? And similarly for Republican, we have 5 plus 5 plus 5, 15 plus 3, 18. So we have total 18. And for other, we have 5 plus 4, so that's been 9. So we have total 40 responses, and out of 40 responses, we have 13 Democratic and 18 Republican and 9 others. Do you have any question? Any question about frequency table? So this is actually a tabular representation of the data. Okay, thank you. So now we'll discuss about relative frequency distribution of qualitative data. So we discussed about frequency distribution of the qualitative data. So now we'll discuss about relative frequency distribution. So what is the relative frequency distribution? The relative frequency distribution is the corresponding frequency to its distinct value divided by the total number of frequency. Yeah. So here, this is the relative frequency. Relative frequency equals to frequency divided by sum of all frequencies. That's mean the denominator will be total frequency or total number of observations, and numerator will be frequency to each value, corresponding to each value. Okay, so we'll go over an example. Okay, so to construct a relative frequency distribution of qualitative data, first you need to construct the frequency distribution. So we already have the frequency distribution of the previous example, right? So now divide each frequency by the total number of observations. So we have the frequency distribution from the previous table. Now we'll divide each frequency by total number of observations. So we have total 40 observations, and corresponding to Democratic, the frequency is 13. So the relative frequency for this one will be 13 divided by 40, which is 0.325. And corresponding for Republican, we had 18 response, the frequency was 18 and the total responses was 40. So 18 divided by 40, which is 0.450. And other is 9 divided by 40, which is 0.225. So this is the relative frequency. Actually, this is also, this is the percentage, right? Basically, this is the percentage. So Democratic, this is 32.5%. Republican, this is 45.0%, and other is 22.5%. So if you add them together, the total relative frequency will be always 1. Because if you add them together, that means you are dividing the total number of frequency by the total number of frequency. So that means the numerator and denominator are same, right? If you add them together, then the total will be 1 because the total is 100%.
Is it okay if we go back to the last slide? My bad. We's in the chat. I just don't think you can see it.
Yeah, sure. I can go back. Yeah.
Appreciate it.
So this one, or the definition of the relative frequency?
The definition of the relative frequency.
Oh, I can just write down for you. So the relative frequency is equal frequency divided by sum of all frequencies, all frequencies. Okay. So you wanted to say this one?
Yeah, that's fine.
Okay, thank you. Do you have any question about frequency and relative frequency? So this is the two tabular representations of the qualitative data or qualitative variable. So then we have some other representations. So this is graphical representation of the data, of the qualitative data. So this is, first one is pie chart. So the pie chart is a disk divided into well-shaped pieces. So that means this is a disk like this, and we divide this one like this. So if we have 3 distinct values, then we'll divide into 3 parts. And this is part will represent the relative frequency of the qualitative data. So this represents the relative frequency, proportional relative frequency. This also represents the proportional relative frequency. This also represents the proportional relative frequency. So to construct a pie chart, the first step is obtain a relative frequency distribution of the data by applying procedure 2.2. So first you need to construct a relative frequency distribution for the pie chart. So first you need to get this one and divide a disk into well-shaped pieces proportional to relative frequency. So the division should be proportional to the relative frequency. Then step 3, label the slices with the distinct values and their relative frequencies. Then you will label slices with distinct values and corresponding relative frequency. So we'll consider the same example to construct pie chart. The pie chart of the political party affiliation data in table 2.1. So we had the relative frequency. We already constructed the relative frequency, right? So we know that the relative frequency for Republican, or the percentage relative frequency, was 0.45. So that's mean 45%. So this is the disk. So you will take 45% of the disk, approximately 45%. So it's slightly less than 50%, right? So if we draw the line like this, then it will be 50%. So this part is 45%. Then other party is 22.5. So this one is 22.5%. And Democratic is 32.5%. So the percentage should be proportional. So when you will divide the disk, you have to divide is based on the percentage. Okay, since we have three distinct values here, right? So that's why we divided into three sections. So the first one is Republican. So you have to label this one with the percentage and Republican. Okay, anyway, we have this, so I do not need to write it. Okay, so this one is Republican, then Democratic, then other. So now the question is, why do we need this representation? Okay, so at the very beginning, we had the data, right? We had this data. So we had only this data. So from this table, what information about the data we can get from this table? What can we tell about the data from based on this table? Anyone? We can only tell we have three responses, right? Democratic, Republican, and other, right? Just looking at this table, do you get any more information about the data? Okay. A general idea of frequency. Okay, just looking at the table, can you tell about the frequency? Just looking at the table. You will not be counting, just you will look at the table. Yeah, we can tell the parity, and by counting, you can get the frequency. Yeah. But without counting, we cannot tell anything, right? Without counting, we can just tell there are three responses, three parties, Democratic, Republican, and others, right? We do not get any other information. So now go to the frequency table. So what can we get? What information we can get from this table? We have some more information, right? Yes, the totals and the corresponding frequencies, right? Yeah. So from this table, we have some more information compared to the previous one, right? So now go to the relative frequency. Now we have more information than the previous table, right? Relative frequency, we can even tell about the percentage, just looking at the table. And if you go to the pie chart, it's also actually tell the same thing, but this is different representation. This is graphical representation. So if someone look at the graph, they can easily see that, okay, Republican has more responses, right? 45%, just looking at the table. Even without looking at the information, looking at the label, anyone can tell that, just looking at the pie chart, anyone can tell that Republican has more responses, right? Then Democratic has the second most responses, and other is the third one, right? Just looking at the pie chart. Even if you do not provide any information, like if you do not provide the percentage. Okay, but if you provide the percentage, just looking at the chart, so we can have more information compared to the first table, right? So that's why actually we need this type of representation. So this is called the graphical representation of qualitative data. Okay, any question? The next one is bar chart. So this is also another graphical representation of the qualitative data. So how do you construct a bar chart? A bar chart displays the distinct values of the qualitative data on a horizontal axis. So you will consider actually two axes. The horizontal axis, this represents the distinct values of the variable. And this axis represents the y-axis, the vertical axis represents the corresponding frequencies or relative frequencies. The relative frequency of each distinct value is represented by a vertical bar. Then we'll construct a vertical bar here to represent the frequency or relative frequency. So you can use either frequency or relative frequency. Usually we use relative frequency to construct the bar chart. Okay, then this bar will represent, the height of this bar will represent the relative frequency, and this horizontal axis represents the distinct value of the variables. And the bars should be positioned so that they do not touch each other. So in bar chart, they do not touch each other. You will also have similar type of graphical representation of the quantitative data, and especially for the continuous data, and they will touch each other, and that will be called histogram. We'll discuss about this later. So how do you construct a bar chart? Step 1, obtain a relative frequency distribution of the data by applying procedure 2.2. So we already know how to construct a relative frequency distribution. The first thing is we will obtain a relative frequency distribution of the data by applying procedure 2.2. Then step 2, draw a horizontal axis, one who is to place the bars. So you will place the bar on the horizontal axis, and a vertical axis, one who is to display the relative frequency. And on the vertical axis, you will represent the relative frequency. Step 3, for each distinct value, construct a vertical bar whose height equals the relative frequency of that value. So we'll construct a bar and whose heights will represent the relative frequency of that value. So step 4 is label the bars with the distinct values. So you have to label each bar with distinct values. The horizontal axis with the name of the variable. And you have to just give the name of the horizontal axis, and that will be the name of the variable. And the vertical axis, you have to also give a name of the vertical axis, and the name should be relative frequency if you are using relative frequency. But if you are using frequency, then the name of the vertical axis will be just frequency. Okay. So here you can see the bar chart of the political party affiliation. So we had 3 distinct values. So Democratic, Republican, other. And this height will represent the relative frequency. So this line represents the relative frequency. So the maximum relative frequency we had 0.45, right? 45% Republican. So the maximum height of the bar will be then 0.45. So that's why we just considered 0.5. The maximum value on the vertical axis is 0.5. The maximum could be actually 1. It cannot be more than 1 because the relative frequency cannot be more than 1. So the maximum height of the bar could be 1. Okay, so the first one is Democratic, and it was 32 point, what was the percentage? 32.5, right? Yes, it was 32.5. So the height of this bar will be 0.325. So this is 0.3. So this is 0.325. Then Republican was 45%. So the height of this bar will be 0.45. So this is 0.45. And this is, it was, the other was 22.5. So the height of this bar will be 0.225. So this is the height of this bar, which is 0.225. So, and now we have to give name to the horizontal axis, and which will be the variable name. So that's when the name of this axis is parity, and the name of the vertical axis is relative frequency. And this is the title of this graphical representation, or of this graph. And the title is, this data is about political party affiliations. So that's why we gave title political party affiliations. So do you have any question? Any question? Okay, so if you do not have any question, then we'll go over some more examples. So this example is about frequency and relative frequency tables. So let's suppose you give a survey concerning favorite color, and the data you collect looks something like the table below. So here the variable is favorite color, and we have these responses. So this is the responses: blue, red, blue, orange. So how many distinct values we have for this variable? So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 different colors. So that means we have 7 distinct responses. So this is our frequency table. So in the frequency table, we have 2 columns. Or you can use 3 columns. The middle column will be tally mark. If you want to use the tally mark, then you can also here you can also have 1 column here, which is called TALLY, tally marks. Or if you just want to simply count the numbers, if you do not want to use tally mark, that's also fine. But tally marks will help you to count the frequency. Okay, so the distinct colors are blue, red, orange, yellow, green, pink, and purple. And the corresponding frequencies are 10, 3, 1, 3, 5, 3, 1. So this is called the frequency distribution or frequency table of the variable favorite color. So now we'll yes, do you have any question?
We're also on a slide procedure 2.4. We can't see any charts or anything that you're talking about.
Oh, so you cannot see this? Okay, so let me, so can you see the bar chart?
No.
Oh, I'm sorry. Okay. Okay, so let me do it again. Yeah, thank you for letting me know.
It's stuck on the procedure 2.4.
Oh, okay,
it says all the steps.
Okay, I think something. Okay, let me fix it. So it's showing there's your screen share. Okay. Okay, so let me log out. Okay, I think something weird happened. I cannot see anything. Okay, I'm sorry about the inconvenience.
Should we leave and come back?
Okay, so just give me 2-3 minutes. I'm trying to fix it.
All right, bet.
Yeah, I don't know what happened. I cannot see anything here in my computer. Yeah. So you can hear me, right? Hello?
Yes, we can.
Yeah, we can
Okay.
hear you.
Yeah. Uh, mm. Yeah, I can just hear you, but I cannot see anything. I even cannot see the Zoom screen. I don't know what happened. Okay. Or I can just sign out and sign in again.